let's continue talking about the chemical reaction part. So, chemical reaction, it is completely rearranging the structure of your compound. So, you will have to break the intramolecular force. So now, how did intra? Alright, so intramolecular forces are being broken. And this intramolecular forces are attraction within a compound molecule. And we know there are two types of intramolecular forces. The very first one would be ionic bond, and the second one would be covalent bond. And we really didn't talk about metallic bond, but metallic bond can be intramolecular forces. Right, so let's write it down. Ionic bond, covalent bond. So again, the one in the parentheses, you're not required to know them, but it's good to know them. Alright, so for chemical reaction, there will be just one graph that you will be responsible to know. This is called reaction diagram or enthalpy diagram. I think you watched a video about this reaction diagram in the very first day of thermochemistry, but I am going to write what it is. So the graph that's going to represent the change for this particular one would be reaction diagram. Some people call it differently, and what you saw, I think what you watched was about enthalpy diagram. So you can also call it enthalpy diagram. Right, so if you're wondering about what this enthalpy means, we're gonna come back to enthalpy because enthalpy needs lots of explanation. It's not that hard, but it may be complicated concept. Alright, so reaction diagram, also it's a diagram, it's a graph, so we need to figure out what the axis is going to look like. So typically we draw this reaction diagram by having y-axis as a potential energy, I guess. And then x-axis as a reaction progress. You may have seen this diagram before in physical science. I am not sure, but probably you should have seen it. So I'm gonna draw a exothermic and endothermic reaction diagram, for example. So potential energy is like the energy that is stored in your bonds. And if you are gonna like take AP chemistry or take chemistry when you go to college, you will know more about this. But I'm gonna make it brief as possible. So we are gonna do exothermic reaction diagram. Exothermic is going to produce the heat. Oh, I forgot to tell you this one as well. This potential energy is going to represent the enthalpy as well. Alright, so because this is exothermic reaction, I need to produce some heat. So you're going to start from high potential energy, and then we need some energy, like the activation energy, to do the reaction. And then you will eventually make a product. So here would be reactant, and then over here would be product. So I hope you can see this difference. You start from here in the potential energy, and then you get that. So when you're delta H, delta means it's a change. When you're going down means a negative. So when you have negative delta H, we call that as an exothermic reaction. And then negative delta H means you are releasing heat. Well, we're going to come back to this one again when we are talking about the enthalpy. Alright, that was exothermic reaction. Then let's do endothermic reaction diagram. I think you have already seen these two. Alright, remember we're just making these notes for us to kind of organize what we have learned. So again, reaction, progress, and then this will be potential energy or enthalpy. Alright, for endothermic process, you will have positive delta H, which means you're gonna start from low potential energy. You're gonna have huge activation energy, and then you'll end up over here, which is going to be higher potential energy than before. So because your delta H is going up, which means it's a positive, and then we call the positive delta H change as endothermic. Oh, I forgot to label these. So reactant, product. Alright, these reaction diagram is really important. It becomes important in kinetics unit as well. So make sure you're familiar with where the reactant is and where the product is. Alright, I think that's about what I wanted to talk about for this particular one, and now you should be finished for thermochemistry notes. There are several things that I do need to add, which will create another note in the future, but for right now, let me know if you have any question about these, and then I will create another video to talk about delta H, probably about Q equals mc delta T, and some calculation. Alright, bye.